Hello, I will be presenting our paper titled Characterization of Historic Mortar Samples and Period Analysis, a Case Study. I'm the first author, Erdogmus, a professor and chair at the School of Building Construction at Georgia Tech. I was at University of Nebraska for several years, as well as at the time of submittal of this paper. I'd like to acknowledge my co-authors. Dr. Mine Hamamcıoğlu is a professor of architectural conservation at Izmir Technology Institute in Turkey. Mr. Joshua Friedland is the director of historic preservation at Bully & Andrews. Ms. Amanda Gaggioli is a graduate student at the Department of Classics at Stanford University. Dr. Michael Hoff is a professor of art history and archaeology at the University of Nebraska-Lincoln. Most of the funding for this work was provided from the National Science Foundation Award number 1559540. The opinions in this presentation are ours and not NSF's. I will talk a little bit about the temple, the monument we're working on, go through the analysis of the site, the hypotheses, and move on to mortar analysis, to archaeological investigations, and conclude with some thoughts about the periods that the evolution of this temple across time. This is an aerial view of the temple grounds as they are now after some excavations and clearing. North is to the side and to the right side here, and we have a retaining wall there because this whole site is on a hill. It's on an incline, and in the front, of course, we have a staircase that was marble at the time to access and ascend to the temple platform. What we see right now is only the first stair, the marble piece in situ, and we see the Roman mortar rubble mix that would have been behind and form the foundation of the platform and the stairs. On the top we see the white marble blocks that form the platform, and the holes were identified as tombs that were put there in the Byzantine era after the initial pagan use of this temple, because we found some jewelry and bones, as well as very specifically misplaced tomb-shaped block areas. And then we see some odd things, which are these perpendicular retaining wall, these two perpendicular retaining type walls. Their architectural purpose was initially unclear to us. And on the western side, we see a flat area and a collection wet that was identified as a wine press. And when we go further down, there's some retaining walls or retaining wall foundation type structure, but it's at an angle to the temple. So when we looked at this as a whole, we wanted to better understand the purpose of these walls and how the time of the retaining wall, these side walls, construction of the temple, and the wine press compared. And we wondered if we could identify these periods that the monument went through an interdisciplinary analysis using both mortar analysis, material studies, and geoarchaeological approach. I should mention that there is one more wall-looking structure here, but that's a trench wall to kind of from the excavation of the back and the front area. In 2019, we removed that because it was blocking some water to the back, and that's not a historical wall. It's just again a trench. Some historical information, essentially general to begin with, because we don't really know the history of this particular imperial temple, why it collapsed. We looked at the historical evidence a little bit, but it's not known when imperial temples in general have ceased operation. It is commonly thought that Theodosian edicts of 390 essentially ended all non-Christian worship, but even after that, it's known that there's been some pagan activity until finally Justinian period ended that for the Roman, for Eastern and Western Roman Empire. So some of the hypotheses we worked on, or we initially had, was by the time this wine press was constructed, the religious activity of the pagan temple had stopped. And this stage of the building's life was after a partial collapse of the front of, at least the front of the temple. And that can be due to natural events such as an earthquake or non-pagan habitants' attacks due to being against imperial temples. Some of our studies, structural analysis towards the hypothesis of whether this was an earthquake or not, is published elsewhere. So you're invited to look at other work for that. But one of the reasons we believe the wine press cannot be contemporary with the temple is, one, because it would be disrespectful to an imperial temple, or that it's, but mainly the reason we believe the front facade or the side walls would have been gone at the time is because there is a relationship we believe that there is between the west side walls and the wine press, and using this flat area on the top as a continuum, and I'll talk about that a little bit more. And in terms of materials and construction style, the front or all of the foundation under the platform is rubble stone with mortar, and then outside for aesthetics there's dry set marble on the outside. Of course the big blocks also have mortar behind them to contain, to adhere to the interior areas. Upper structure is entirely of dry set marble blocks, no mortar, and there is some evidence of mechanical attachments, but not as much as common in some of the other Greek temples. Very minimal mechanical attachments. So one of the main questions we asked when we were studying the site was, is this northern retaining wall contemporary with the temple or not? Retaining walls, of course, in a hilly, inclined site behind the structure are common, but the reason we were suspicious is it was built so close to the temple, creating this very narrow area in the back, and some of the marble in the back was intended to be decorated, molded, even though most of it was unfinished. There was an intention of a pretty nice back facade of the temple. So being this narrow and close to the temple would avoid viewing of these details, but it would also create some water issues on that back area. So we wondered if maybe that is a later solution when there were issues that was observed. And then the rubble walls on the other side, perpendicular to the temple, have very similar construction style to the retaining wall. So at an initial glance, it could have been thought that they are contemporary, but again, architecturally they do not make a lot of sense. Structurally they do not make a lot of sense. There's no reason to support a large marble temple with small walls perpendicular like that. And we found drainage holes at the bottom, which indicated there was some sort of a water channel type function to that area. So again, when we look at this aerial view where these walls are, we're comparing this back retaining wall to these perpendicular walls, and when we closely inspect, the workmanship is also different, and the revels are relatively larger in these perpendicular walls compared to the back wall, and the retaining wall has tighter mortar joints, thinner. So it seems that there was more attention to building a strong wall for the back compared to these side walls in terms of mortar joint thickness. But the stone types appear to be from the region, and all of them had similar geological characteristics. When we look at the vine press, the elements we can identify are the threading floor where the grapes were crushed, and then right next to it a collection vat, and so that was how we identified this as a wine press. And there has been a study specifically for the wine press of this site by Dodd in 2020. It's a published electronic book. Very, very interesting. I highly recommend it. And he did suggest that this unused platform was used as a space to dry grapes on mats for the creation of raisin wine. That's why, again, we agree with that, because that would have made a general flow of work, as long as there weren't tall temple walls or cella walls on the way. So that's why we believe that the deep destruction of the walls in the front of the temple happened before the wine press got in. So here's the hypothesized winemaking flow. Potentially this area with the drainage holes and the walls was used for storing, was used for washing the grapes, and right next to it, likely the flat area was easy to store or first dump the grapes, and then the top of the platform was used for drying, and the flat area that was particularly created and plastered was used for grape crushing, and eventually the storage and the fermentation of the wine happened in the back. Looking at the same view then, the samples of mortar we collected, M1 through M5, are from different areas, different structures. M1 was collected from the front staircase mortar, M2 from the wine press, interior walls, M4 is from the side of the wine press, or from this flat area, and M3 was from the walls that are on the other side, and M5 from the back retaining. Here's a tabulated summary of our samples. And on the top you can see a picture. All of the samples we got were irregular, and of course aged and somewhat contaminated with other dirt around, but we identified their location, and all of them were identified as hydrated lime sand mortar after all the analysis. So at a glance, the aggregate or the binder seemed similar in all cases. The analysis methods we used were X-ray diffraction, scanning electron microscope, and optical microscopy of thin sections. The first two were done at Izmir Technology Institute labs, and the last one was done in the United States by Joshua Friedland when he was at Jenny Elsner in collaboration with his colleagues at the WJE Chicago labs. Next few slides I'll present some results from these analyses. So this is the SEM on the left results for sample 1. So this shows that in some portions of the mortar there are layers of clay minerals, and the detailed analysis of the materials through XRD state that the binder was amorphous in texture, mainly composed of calcium carbonate. And calcium carbonate is likely from the calcite rock that was used to produce the lime. And two also less common materials were observed, muscovite and quartz. And it is speculated that the presence of these in the material is related to lime production on site. And here we see again the first sample results from the thin section analysis under different polarized light observations, and we see from this that the sample contained hydrated lime lumps. The lime lumps were typically smaller than 0.5 millimeters, but there were some that are larger, 3 to 5 millimeter. Some shrinkage cracks were also observed, and those are typical for lime-based mortars. Here we see the shrinkage cracks in the red, and the hydrated lime lumps in yellow, hydrated lime lumps with the red arrows, and shrinkage cracks with the yellow arrows. And detailed analysis of the sample 2 here of the contents. The sand in the samples consists primarily of calcite, mica, quartzite, and metamorphic rock fragments. And the maximum size sand particles range from 4 millimeter to 8 millimeter, and they are subangular to rounded, well-graded, and uniformly distributed. The variability in volume of sand is observed between the samples, with fewer fine-sized sand in M2 than in other 4 samples. Presence, and remember that this is the mortar around the wine press, so sample 2. So presence of more binder and less sand is likely related with the intention to have a more durable more fine mortar to almost like a plaster. So here we see all of the samples together from the thin section analysis, and on the side we have the locations of the sample to remind you all. So the voids that are irregularly shaped, that are all blue in these images, likely contained free water when the mortar was installed. So you can see the volume of voids varies between the samples. They were lined with secondary calcite crystals, indicating moisture migration through the samples over time. And this can be the reason why we see deterioration of mortars in relation to the overall weathering and accumulation of water around the temple. So M3 and M4 specifically show abundant amount of void space, and those are the mortar and plaster samples from the Byzantine walls. The difference between void volumes may be related to placement techniques in addition to variations in initial water to solid ratio of the fresh material. M2 also has relatively more binder, as mentioned before, and that was the lining of the wine press walls. Interestingly, in sample M4, we see some cellulose fibers, and in Byzantine era, this was common to use fibers to reduce shrinkage and improve tensile strength. So that was very interesting. And finally, sample M5, which is from the back retaining wall, contains a larger volume of very fine-grained sand, including mica, quartz, calcite, and that was dispersed through the paste as compared to other samples. And the paste in sample M5 is brown in color, extremely soft and porous, indicating that the lime amount is relatively lower. So here we see a larger view of the M5 sample under tin section analysis. And again, this sample contains dissimilarities of sand compared to the other four, especially where the maximum size sand particle is typically less than 2 millimeters. So in general, it's much finer than the other four examined samples. There are also irregular voids and shrinkage cracks. We still see hydrated lime lumps and that are in various sizes that are indicated by yellow arrows in the picture. And XRD also shows a difference, weaker peaks for calcite and stronger peaks for quartz. And the interesting appearance of clinocrystolite, which is common in the Antalya region, was also seen. So when all the differences in mortar composition are evaluated together with the difference in workmanship of the wall, it may be concluded that the retaining wall was constructed at a different time, or at least using a different technique for other reasons. Now I'll quickly talk about the geoarchaeological investigations. Geoarchaeology is an interdisciplinary discipline which combines subjects of earth sciences in order to inform interpretations of archaeological excavations and explore geological aspects of the human past. This part of the work was done by our Stanford graduate student Amanda Gaglioli, and she did some field work collecting block samples and started thin section analysis of those samples later on. So a continuous set of soil blocks from 3 strategic areas were sampled, and these included 1 sample below the foundation level of the structures and 2 at the occupational level of the structures and 1 just above the occupational level of the structures, the foundation. The documentation involved recording major changes in the stratigraphy of the exterior of the temple in each of these areas and classifying the soil texture for each identified stratigraphic unit. These classifications will be refined during the soil micromorphological analyses, and this requires the use of a petrographic microscope and Fourier transform infrared spectroscopy FTIR to analyze microfeatures in elemental compositions. So this work is in progress right now, but we will use some of these early findings to support the material analysis in this paper. So findings thus far is that temple foundation sits almost directly on limestone bedrock, and the various accumulations of column in the stratigraphic sequences of the northwestern corner, northeastern corner, and north end of the temple are attributed to the temple's geological setting on a steep hill slope with the hill inclining to the north. In each of the three study areas, columbium inclines in a direction parallel to the hill slope and demonstrates its movement from north to south. Again, north is the higher part of the hill, south is lower. Above layers of columbium, there is an accumulation of boulders and mortar in a layer ranging from approximately 20 to 50 centimeters in both the northwestern and northeastern corners of the temple. This layer is interpreted to be building debris from a destruction event. And the 40 to 50 centimeter accumulation of columbium underneath the level of building debris in the northwestern corner demonstrates that the building's function as a temple in this area discontinued prior to its larger destruction in a later period, since the columbium accumulated gradually, whereas the building debris appears to have occurred more suddenly. So the construction date of the terrace is unknown, but given that the foundations of the temple and terrace are at the same stratigraphic level, it is most likely that this terrace was built to prevent the columbiation of the temple at the time of its construction. The sedimentary sequence above the temple foundations in the northeastern corner is interpreted to be the result of several events of anthropogenic activities involving the dumping of waste. So it's likely that the social function of the temple changed prior to its full destruction, as revealed by large mortar boulders and mortar falling deposited in a direction falling away from the temple. The northwestern corner, on the other hand, went into disuse prior to the temple's larger destruction event, as revealed by the accumulations of hill slope columbium under the layers of architectural debris. So we're moving on to the conclusions, putting together all of the visual, material, and geoarchaeological analysis we've done. We identified three distinct construction styles. Temple foundation had rubble core finished with cut stone blocks. Mortar rubble of small and medium sizes with thicker joints were used at the wine press installation. That was both the flat crushing area, the vat, as well as the perpendicular walls. And mortar rubble of medium sizes were put tightly together with small mortars joints at the rear retaining wall. While all of the mortar samples contain locally available lime and sand, their composition and characteristics slightly varied. Presence of less sand and more binder in the mortars of the press indicate a desire for better mechanical strength, and use of fibers indicate a desire to improve water resistance and durability. However, the findings in general differed a little from our initial hypotheses. Samples 1 and 5 are expected to be similar and belong to the initial pagan temple use phase. Again, M1 was from the front foundations and M5 from the back retaining wall. And samples M2, 3, 4 are expected to belong to the later use phase, therefore be more similar. However, the most different sample was M5 compared to the 4. So that could mean the retaining wall was constructed at a different time compared to the temple platform. But then the foundations of the temple and terrace are at the same stratigraphic level, and it's common construction practice to build a retaining wall when a structure is constructed on a hill on an excavated site. So the differences then are likely the result of a less considerate workmanship given the wall's purpose and its location away from the eyes of the public. The purpose and construction time of the walls perpendicular to the temple on the east side was another question, and we found similar material composition of these walls to those from the wine press, and the drainage holes do suggest a function related to washing the grapes or drainage of other fluids. And the debris found in geoarchaeological investigations support this theory. However, lack of waterproof plaster in the mortar samples from the area challenges this theory. But given no other architectural and structural reasons for the construction of these walls, the governing hypothesis related to these walls remains to be a function related to the wine press installation. This study contributes to the knowledge of mortars, plasters, and construction methods from the early Roman and Byzantine eras in Anatolia, and the unique interdisciplinary work utilizing both material analyses and geoarchaeology strengthens the conclusions that can be drawn from either discipline alone and provides more support for the hypotheses of the phased destruction and changing use of the monument. I would like to thank you for your attention, and for questions or discussion of this work, please email me at the given email address. Thank you.